talking about ratios and similarities. So all of this is going to be easy. We're just talking about ratios and proportions. So for the first blank, this should be a ratio. So a ratio compares two numbers by division. So if you notice right here, there's an example of a ratio. The ratio is just a fraction, 1/2. And there's several ways that you can write ratios. You can write it in fractional form. You can write it with a colon in between them, or you can just say 1 to 2. But the most common way that we see it is as a fraction. And in the next blank, this would be the ratio. The ratio of two numbers, A and B, can be written as A to B. So A and B are my numbers. So you can write it as A to B, and they listed it right here, 1 to 2. Or you can list it with a colon, so that would be A colon B, and they have the same right here, 1 colon 2. Or you can write it in fractional form, which would be A over B, where B cannot equal 0. And the reason why B cannot equal 0 is because you cannot divide by 0. So if you go into a calculator and type in 1 divided by 0, it'll give you an error message. So the bottom number cannot be 0. That's just FYI. Okay. Next part. Example 1. It says to write a ratio expressing the slope of line M. So we're looking for slope. So when we talk about slope, we call it rise over run. And when you write it as a fraction, that is called a ratio. So slope is just a ratio. Rise over run. So line M, I need to first make sure I'm looking at the correct line. So let me highlight this one in red. So here is line M, and I know it's line M because it has this little M right here. So we're looking at line M, and we're looking for the slope of that line. So they gave me this point, and they gave me this point. So I'm going to make my right triangle, and we're going to count the rise, and we're going to count the run. So the rise is movement up or down. So how many do we go up? 4. And how many do we go over? 4. So the rise is 4. The run is 4. And slope is always in simplest form. So 4 divided by 4 is equal to 1. Easy, right? I said it's easy. It's going to be easy. Okay, next part. Example 2, the ratio of the angle measured in triangles is 1 to 6 to 13. What is the measure of the smallest angle? So that means the smaller angle is going to have the 1. The next biggest angle has the 6. So it's going to be 6 times the 6 as the first one. And then the biggest one is 13, which means it's 13 times the smallest angle. So what I'm going to do first is I'm going to draw myself a diagram. And we're talking about what shape here? We're talking about a triangle. And since my ratio is 1 to 6 to 13, that means all 3 sides are not equal. Okay, so they told me the ratio of the angle is 1 to 6 to 13. And we're looking for the smallest angle. Do we know the size of the smallest angle? No, but what I need to do is use these ratios. So I'm going to say this one over here is my smallest angle. So I'm going to call that 1x. X's are unknown. So that means my second biggest angle, since the ratio is 1 to 6 to 13, the next biggest angle would be the 6x. And And then the biggest angle, my obtuse angle here, would be 13x. So use the ratios and just put x with it, and we're solving for that unknown. Now, we learned last week that if you're talking about the angle measure, so if you're talking about angle measure, if I add, well, so technically this would be 1x degrees, 13x degrees, 6x degrees, technically. And if I add all three interior angles inside a triangle, they all three add to how many degrees? 180. So do that. So we need to do 1x plus 6x plus 13x equals 180 degrees. Now, technically you don't need to have the 1 in front of the x, but I wanted you to see the 1, the 6, the 13. So, solve this equation for x. I need to combine my like terms. So 1 plus 6 is 7. What's 7 plus 13? 20. So that gives me 20 for the x's. That equals 180. What's next? Divide those sides by 20. X equals 9. Now, the thing about geometry, are they normally asking you for this x? No. What do they ask us for? We want the smallest angle. So looking at my diagram, which one is the smallest? 1x. So for the smallest angle. So the smallest angle is 1x. Yes, replace the x with a 9. So we need to do 1 times 9. And 1 times 9 is 9 degrees. So the smallest angle is 9 degrees. Now, on the assignment, they may ask you for the biggest angle. So if they ask you for the biggest angle, how would you find the biggest angle? Yeah, do 13 times 9. Okay, so that one was easy too. Next part, the cross product property. It says that in a proportion, if this is going to be A over B is equal to C over D. So that is a proportion. A proportion is when you have two fractions that are set equal. So a proportion is when two fractions are set equal. And we need to fill in the blanks, and it says B and D cannot equal 0. So you cannot divide by 0. So the two bottom numbers can't be 0. Then, here's how you solve a proportion. You multiply the diagonal. So this would be A times D. And when you do A times D, we write that as AD. And when I multiply the second diagonal, B times C, we write that as BC. So to solve a proportion, you find those cross products. And those cross products, you set them equal. So we'll have some examples of these where we are going to solve these proportions. So example 3 says solve each proportion. So I know this is a proportion because I have a fraction equal to a fraction. So to solve a proportion, you find your cross product. So multiply this diagonal. Yeah, y times 45 is 45y. Set it equal to the other cross product. So if I multiply this diagonal, what is 5 times 63? 315? Solve for y. How do I get rid of the 45? Divide both sides by 45. Y equals 7. So to solve a proportion, you set your cross products equal. So multiply the diagonals, set them equal. Okay, so more practice. Problem B. Now, it doesn't matter which diagonal you multiply first. I just always multiply the diagonal that has the variable. So for this one, I'm going to multiply this diagonal first because it has the D. So when I multiply this diagonal, what's D times 2? 2D. Set it equal to the other cross product. So when I multiply this diagonal, it's 3 times 6. 18. I get rid of this 2? Divide both sides by 2. So this gives me D equals 18 divided by 2 is 9. So D equals 9. Okay, this is letter C. So again, I always multiply the diagonal that has the variable first. So what is 2 times 4y? 8y. Set it equal to the other cross product. So for this diagonal, what is 9 times 8? 72. Divide both sides by 8. And what does y equal? 9. Easy stuff. Easy. Okay, next part, example 4. It says, during the filming of The Lord of the Rings, the special effects team built a model of Sauron. How do you say that? Sauron? Sauron's tower with a height of 8 meters and a width of 6 meters. If the width of the full-size tower is 996 meters, what is the height? So, they gave us 3 out of 4 things. So we're going to solve this using a proportion. So what 2 things do they tell us? We're talking about the height and we're talking about the width. So we're going to write up a proportion with height and width. So I'm going to use H for height, W for width. So height go on the top, width will go on the bottom. Okay, so fill in the blank. So the first height, what was the first height? 8. So 8 goes on top, so heights go on top. And the width is 6. So 8 on top, 6 on bottom. And then the third one they gave us, they told us that the width is what? 996. So if that's a width, do I put it in the top or in the bottom? Bottom. So 996 goes on the bottom. And we're solving for the height. You could put X, I just put H for height. So I remember I'm solving for height. Now, when I solve this, I always multiply the diagonal that has my variable. So if I multiply this diagonal, what is 6 times 8? 6. Set it equal to the other diagonal. So what is 996 times 8? 7,968. How do I get rid of the 6? Divide both sides by 6. And the height is what? 1,328. Now, with math, we need units. Yes. So 1,328 meters. Okay, on the back. Okay, now we are going to move on to similar polygons. And it says that 2 polygons are okay, so your handout is missing something. No, your handout has it, right? Yours has this. And then yours has this. Okay. So it's mine that's missing information. Okay, so this symbol right here, I do want you to make a note that this symbol right here means similar. So if you see that little wave, it means that your polygons are similar. So this says 2 polygons are similar, and then this double arrow means if and only if. So 2 polygons are similar if and only if their angles are congruent. So I'm missing this symbol. So the angles are congruent. and the corresponding sides are proportional. So two polygons are similar if their angles are congruent. So all the angles are equal, so angle pairs are equal, and their corresponding sides are proportional. So we are given polygon ABCD and polygon EFGH. We are going to show that all four angles are congruent and that their sides are proportional. So let's start with angle A. So angle A is equal to which angle on the second figure? E. So angle A is congruent to angle E. Angle B has one arc mark, so angle B is congruent to angle F. Angle C has two arc marks, so it's congruent to angle G. Angle G also has two arc marks. And then I'm missing the angle sign here. So angle D is congruent to angle H. Missing the congruent symbol here. So angle D is congruent to angle H. So far it's looking similar because their angles are congruent. Now we need to show that their corresponding sides are proportional. So we're going to find the similarity ratio for ABCD to EFGH. So that means I need the first one compared to the second one. So ABCD, let's start with this side. So 5 corresponds to what on the second figure? 5 to 10. So this needs to be 5 over 10. And 5 over 10 simplifies to what? 1/2. 1/2. Okay, looking at the top. This one is 6. What is the top on the second one? 12. And 6 over 12 simplifies to 1/2. The next side, this one is 5.4. 5.4 corresponds to what? 10.8. And that fraction simplifies to what? 1/2. And then the last one, 4 corresponds to 8, which simplifies to 1/2. So in order for the polygons to be similar, all angles have to be congruent, and then these proportions of all the sides have to be the same proportion. So notice we had 5 over 10, 6 over 12. Those weren't the same numbers, but when you simplify them to simplest terms, they all equal 1/2. Now the second part, now they want us to reverse it. So that now they want us to compare EFGH is going to be the top number, ABCD is going to be the bottom number. So now go backwards. So starting with the bigger one, this one is 10. So 10 corresponds to what over here? 5. So 10 over 5. And 12 corresponds to what on the first one? 6. So 12 is 6. And 10.8 corresponds to 5.4. And 8 corresponds to 4. And if you divide all of those divide to simplify to 2 over 4. So it doesn't matter if you do the ratio of big to little or little to big, they will all simplify to the same number. So the similarity statement, we will say that polygons ABCD, and we can't say that they're congruent because are they congruent? No, they're not congruent, they are similar. So we use that little wave to show that it's similar to the second polygon, which is polygon, and you make sure I get it in the correct order. So if I did A, B, C, D over here, it used to be E, F, G, H. E, F, G, H. So we use that little way to show that they're similar. So to be similar, they have to have the congruent angles, and then their sides have to be proportional. So they have to simplify to the same ratio. Okay, example 1, it says determine whether the polygons are similar, identify the corresponding angles are congruent, and corresponding sides are proportional. If so, write the similarity ratio and a similarity statement. So let's go over here and say that when we simplify, this is called your similarity ratio. Same thing with the 2 over 1. That is called your similarity ratio. So what they all simplify down to. That's called your similarity ratio. Okay, so they told us that we have to identify corresponding angles are congruent. So let's start with that. So problem A, we are given rectangles PQRS and rectangles PUVW. So the first thing we have to do is identify the angles. Well, what are the angles? What are all 4 angles in a rectangle called? Right angles. So all of these are how many degrees? 90. So let's mark them up. So this one, 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 this one. And instead of saying that angle P is congruent to angle T, angle Q is congruent to angle U, I don't want to have to do that 4 times. I'm just going to say that all angles are congruent right angles. So far they look similar because their angles are all the same. They're all congruent. Now we need to check the size. So it doesn't matter if you do small to big or big to small. I'm going to do small to big. So let's see. If I have 4 corresponds to what on the big one? 4 over 6. And then for the top, this would be 12 corresponds to what? 16. And this one, well, really, do I really have to do these? No, because this would be 4, this is 12, this would be 16, this would be 6. So for a rectangle, you really just have to check 2 of them. Okay, so let's simplify those. So to get these in simplest form, 4 over 6 simplifies to what? 2/3. And 12 over 16 simplifies to? Both of those can be divided by 4, so what's 12 divided by 4? 3, and 16 divided by 4? 4. So, are those equal? No. So I'm going to put slash through it, Those are not equal. So if they don't have the same proportion, that means they're not similar. They're not similar. So I'm just going to say the polygons are not similar. So if the sides are not proportional, they cannot be similar. Next one, part B. This time we're moving on to some triangles. We have triangle ABC and triangle DEF. So the first thing we need to do is determine if the angles are congruent. So I can say that angle A is congruent to what other angle? 1 arc mark, 1 arc mark, I agree, that would be angle B. And 2 arc marks belong to angle B. So angle B is congruent to angle E. And remember that theorem, the third angle theorem? If I have two sides or two angles that are congruent, what do I know about the third angle? The third angle is also congruent. So angle C gets 3 arc marks, and angle F also gets 3 arc marks. And we can say that angle C is congruent to angle F. And you can make a little note called the third angle theorem. So if you have two pairs of angles in a triangle that are congruent, the third pair is also congruent automatically. Okay, so far it's looking similar because we have 3 angles that are congruent. Now we need to check their sides. So I'm going to do the first one to the second one. So 16 corresponds to what on the other one? This one corresponds to 6. Ooh. Wait, we have to be careful. We have 1 arc mark, 3 arc marks. So 1 arc mark, 3 arc marks is actually 12. So be very careful. They turned it on us, try to trick us. Okay, so we did that side. Next one I'm going to do is going to be the 20. So I'm going from 1 arc mark to 2 arc marks. So that would be 15. So the last one would be 24 to what? 24 to 18. Now I need to simplify those and make sure they simplify down to the same thing. So 16 over 12, both of those can be divided by 4, so it's 16 divided by 4. 4, and 12 divided by 4 is 3. 20 and 15 can both be divided by 5, so 20 divided by 5 is 4. 15 divided by 5 is 3. Looking good so far. And the last one, 24 and 18, can both be divided by 6. So it's 24 divided by 6. 4 and 18 divided by 6, 3. So are those triangles similar? Yes. So we can say that triangle ABC is similar, so do the little wave. So triangle ABC is similar to triangle DEF. And then they said that if they are similar, you have to give the similarity ratio. So our similarity ratio is 4/6. So you needed both of those. Yes, they're similar, and the similarity ratio was 4/3. Now, if you did the second one to the first one, then instead of 4/3, it would be 3/4. Okay, example 2. Find the length of the model to the nearest tenth of a centimeter. So we have 3 out of 4, so set up a proportion. So on this diagram, we're comparing the length and the width. So I'm going to do L for length, W for width. So for the top car, the top one is 5 meters, and its width is what? 1.8. Second ratio is for the model. So what do I put for the length for the model car? Okay. And for the width, I put 6.3. Solve a proportion by cross multiplying. I always multiply the diagonal with the variable first. So what is 1.8 times x? 1.8x. Set it equal to the other cross product. And what is 5 times 6.3? 31.5. And how do I get rid of the 1.8? Divide those out by 1.8. X equals what? 17.5. Now I need some units. So the top one was meters, but we're looking for the model part, so what units do we put? Centimeters, so 17.5 centimeters. Okay, guided practice. They ask us to write a ratio expressing the slope of each line. So for line L, remember slope is rise over run. Line L, let me change this to blue. Line L is this one. Now on the note, they gave us points. But did they give us points on the lines this time? No. But I can see a point right here. And I can see a point right here. Make a little right triangle so you can count the rise and count the run. So what is the rise? 3. What is the run? And 3 divided by 1 is 3. Problem 2, we want the slope from line N. So they gave us a third line just to try to trick us. So here's line N. They didn't give us points, but I can see a point right here. And I can see a point right here. Make your right triangle. And again, slope is rise over run. So what do I put for the rise? 3. What do I put for the run? 2. So 3/2 for the slope. Number 3, the ratio of the side lengths of a quadrilateral is 2 to 4 to 5 to 7. And its perimeter is 36. What is the length of the shortest side? Now, a quadrilateral, quad, how many sides does a quadrilateral have? You're right, it's 4. And let's see, the ratio is 2 to 4 to 5 to 7. I'm going to draw myself a quadrilateral. So this time, instead of angles, we're talking about side length. So the shortest side length, I'm going to make that one 2x. And then the next one would be 4x. Next one is 5x. And what about the longest one? 7x. This time, they're talking about perimeter. What does perimeter mean? Yeah, the distance around the figure. So we need to add all 4 sides together. So let me start with the smaller one. This would be 2x plus 4x plus 5x plus 7x. And when you add all 4 of those together, they said the perimeter was what? 36. The perimeter is 36. Combine your like terms, so 2x plus 4x is 6x, 6x plus 5x is 11x, and 11x plus 7x is 18x equals 36. How do I get rid of the 18? Divide both sides by 18. 36 divided by 18 is 2. Did they ask us to solve for x? No, what did they ask us for? We want the length of the shortest side. So which of those is the shortest side? 2x. Shortest side is 2x, and you are right. It would be 2 times 2, which is 4. But I need some units, and what units were they using here? Meters. So the shortest side is 4 meters. Okay, question 4 says identify the pairs of congruent angles and corresponding sides. So let's see, angle M is congruent. It has 1 arc mark, so it's congruent to angle U, one arc mark, one arc mark. Next one, two arc marks. That would be angle N. It is congruent to angle B. So 2 to 2. And in a triangle, that third angle theorem says if you have two pairs of angles that are congruent in a triangle, the third one is congruent as well. So that means angle P is 3 arc marks, and angle W is 3 arc marks. So that would be angle P is congruent to angle W. And now we need to identify corresponding sides. So let's see. Side, let's start at the top. Side MN. And I'm just going to put an arrow saying it corresponds. And so MN, if I look at these, MN corresponds to what? UV. So we did MN, next one would be NT. So NT corresponds, so NT corresponds to VW. And the last one would be PM, so side PM corresponds to side, so PM corresponds to WU. So that one's just identifying the user. Number 5, determine whether the polygons are similar. If so, write the similarity ratio in a similarity statement. So your similarity statement would be triangle ABC is similar to triangle DEF. Okay, so first of all, are the angles congruent? Yeah, angle P is congruent to angle U. Let's see, angle M is congruent to angle W. And if I have two pairs that are congruent, then I know the third pair is also congruent by the third angle theorem. So by the third angle theorem, angle R is congruent to which one? Angle X. So far the angles are congruent. Now I need to do the side ratio. So let's see, RM. So RM corresponds to XW, so XW is 12, so that would be 8 to 12. Next side, MP. MP is 10, and MP corresponds to WU, which is 15. W 10 to 15. The last one would be 4 to what? 4 to 6. Simplify those. 8 and 12 can be divided by 4, so what's 8 divided by 4? 2. 12 divided by 4? 3. 10 and 15 can be divided by 5, so what's 10 divided by 5? 2. And 15 divided by 5 is 3. 4 over 6 simplifies to 2/3. Did we get the same similarity ratio? Yes. So are those triangles similar? The answer would be yes. So I'm going to say that triangle, using these, this would be triangle PMR. PMR. Similar, use the wave. So similar to triangle UWX. UWX. Then I also need that similarity ratio. So a similarity ratio. Yeah, you can put that there. And our similarity ratio is 2/3. So make sure you have your similarity statement and the similarity ratio. Okay, last one, we made it. Number 6, the town of Goodland, Kansas claims that it has one of the world's largest easels. It holds an enlargement of a Van Gogh painting that is 24 foot wide. The original painting is 58 centimeters wide and 73 centimeters tall. If the reproduction is similar to the original, what is the height of the reproduction to the nearest foot? So they tell us that the reproduction is similar, which means that the size would have to be proportional. So the easiest way to solve this, write yourself a proportion. And the two things we're comparing here is we are giving the width and we are given how tall it is. So I'm going to use W for how wide it is, T for how tall it is. Now it says it holds an enlargement of a Van Gogh painting that is 24 foot wide. So where do I put the 24? Top or bottom? Top. We don't know how tall that one is. They didn't tell us. So I'm going to put S. That's the unknown. We're solving for that. But they tell us that the original painting is 58 centimeters wide. So where do I put the 58? Top or bottom? If it's wide, it needs to go on the top. The wide goes on top, and 73 tall, so 73 goes on the bottom. Cross multiply, always do the one with the variable first. So what is x times 58? 58x. Set it equal to the other cross product. What is 24 times 73? 1,762. Divide both sides by 58. Well, what did you get before? 30.2. 30.2? Was it exactly? 32.2068. Approximately. But they said to round that to the nearest foot, so to the nearest foot, that would be 30. Okay, 30 feet. Okay, the rest is for you.